Good morning, students. Our today's topic is equation of motion. We know that we have basically three equation of motion, and these are: first one is v is equal to u plus at. The second equation is s is equal to ut plus half at square. The third equation is v square minus u square is equal to 2as. Okay, in these equations v is final velocity, u is initial velocity, a is acceleration, and t is time taken, and s is the total distance or the displacement traveled by the object. Okay, now we have to know about how these three equations can be derived for any kind of motion. So these equations can be easily derived with the help of a graph, and this graph is a velocity time graph for any accelerated motion. Okay, so in the previous topic we have already discussed about the different graphs, and in a velocity time graph, on x-axis we take time, and on y-axis we take velocity v. Okay, so if at t is equal to 0, let object has some initial velocity u, and after that the velocity is increases with time. Okay, so this is then velocity time graph for an accelerated motion. Now in order to derive first equation, okay, we already know that the slope of a velocity time graph gives the acceleration. So we can say acceleration is equal to slope of this graph. So acceleration is represented by a, which is further equal to slope of this graph. In order to take the slope, we consider 2 points, say point u, or we can say a point a. Okay, so the velocity correspond to first point is u, and the velocity correspond to second point is, say, v, and the time correspond to this velocity is t. Okay, say time correspond to initial velocity is 0. Okay, now the slope of this graph is given by the ratio of change in y-axis to the change in x-axis. Okay, so we can write here acceleration is change in y-axis divided by the change in x-axis. Okay, now as from the diagram the change in y-axis is this distance, say this point is b, so we have to calculate ab, and this ab must be equal to vu. Okay, and this distance vu on the velocity axis is obtained by, this is the final velocity v. If we subtract u from this, then we get this distance vu. Okay, so the AB must be equal to V minus U. So change in y-axis must be equal to V minus U. Okay. Similarly, the change on x-axis, here it is 0 and time is t. So t minus 0 is the change in x-axis. So we can write here A must be equal to V minus U upon t. t minus 0 is t. So multiplying this t with a, we get at is equal to v minus u, or we can say v is equal to u taking other sides, so we get u plus at. Okay, this is our first equation, say equation 1. Okay, now for the second equation, as we know that the area under this velocity time graph, area under this graph gives the total displacement. So this area gives the total displacement. We can write the total displacement or distance is equal to area under the graph, VT graph. Okay, so in order to calculate this area from the graph, we know that this area can be obtained in two segments. First one is this area of the triangle, and the second one is the area of this rectangle. Okay, so we can write area by the addition of these two areas. So the displacement, that is S, must be written as area, that is area of triangle plus the area of a rectangle. Okay, now as we know that area of triangle is given by half into base into height.